everybody, welcome back to yet another video of FikarNot.com, now FikarNot from Studies. So this is the part 2 video of our chemical reactions chapter. In the previous session, we learned about different type of chemical reactions, chemical changes, and the direct combination reaction, decomposition reaction, double decomposition reaction, and now we're just learning about the double decomposition reaction, neutralization, and moving on. So we'll finish the chapter in this video today. And before I do so, let's just have a quick recap of what we did last time. First and foremost, what is a chemical reaction? Well, as we all know, chemical reaction is a chemical change in which matter changes into new substance or new substances. And at the left side, you have the reactants. At the right side, you have the products. And the types of chemical reactions I just told: direct combination, decomposition, displacement, and double decomposition reaction. Now in combination, what happens in combination reaction? You have A plus B gives you AB, right? So they're combined together. Then the second one, in decomposition reaction, you have AB turns into A plus B, right? Then you have the displacement reaction, in which you have A plus BC, and among A and B, whoever has the more, whoever is higher in the electrochemical series that we see, right? The K, Na, Ca, Mg, Al, Zn, Fe, and so on. Whoever has a more higher position in the electrochemical series is basically displaced. So let's say A is higher than B, because let's say A is K and B is Na. So definitely K is the topmost, right? It has the most power of all. So it can displace A with B, and therefore your total answer becomes AC plus B. Then the last and final one you have is double decomposition reaction. In double decomposition reaction, what happens is a chemical reaction in which two reactants are both minus and they're decomposed to form new substances. So they're basically exchanging the radicals. So again, one more example would be A plus B minus, right? Plus C plus D minus. So A is with minus, it is changing, and it is basically displacing with equals to AD. So that's A plus and D minus, plus C always comes first, right? The plus sign always comes first. So C plus and B minus. So basically you're changing and exchanging your radicals, and this is your final outcome. Alright, you're basically displacing it, but you can also see decomposition, because you are decomposing in a way. Why? Because AB is being decomposed into two. A is over here and B is over here. So two different products. So it is double decomposition reaction, because you are decomposing two times. First, you are decomposing AB and you're adding D to it. Then again you're decomposing AB and you're adding C to it. So it becomes AD, A plus D minus plus C plus B minus. Alright. So again, today we're going to continue our chapter, and we have about 3 to 4 pages left, so it won't take very long. But we're going to do our neutralization reaction in this chapter, and we're going to see all the energy changes, etc. Alright, so without further ado, let's get into the video. Okay, so double decomposition reactions are chemical reactions in which both reactants, compounds, are decomposed to give new compounds by exchanging their radicals, as I just said. So they are decomposed in a way to give new compounds. So instead of AB as a product, you get AD. Instead of CD, you get CB. So you're exchanging their radicals and you're decomposing them, right? So in neutralization reactions, reaction between two compounds, that is a base and an acid. Let's take a simple example, okay? So to give new compounds, salt and water. Let's take this example. Alright, it's a very easy one. Na, okay, let me take a different color so that you can see it very, very properly. Okay, Na plus OH minus plus C plus Cl minus. Right? So basically, if you take out the radicals and just write it in a normal form, it is basically NaOH plus HCl. So if you see in a way, NaOH is a base because it's hydroxide. You have hydrogen, you have oxygen, it becomes a base for sure. But over here you have hydrogen, and whenever for making an acid you need hydrogen, right? So HCl is an acid, we all know, hydrochloric acid. So when you combine both of them, this is what you call neutralization reaction. So what happens is they're displacing and they're decomposing, right? They're displacing and they're displacing also, they're decomposing also. Decomposing in a way where AB turns into a different compound and CD turns into a different compound to give two or more new compounds, or in this case two new compounds. So you are changing your radicals and Na will go with Cl, right? So it becomes NaCl plus H2O, right? Because there's 2 H and 1 O. So what does it become? NaCl plus H2O. Now, if I just say it in words, what do you think this is? Well, clearly it is, instead of sodium, it is sodium chloride and H2O, right? Sodium chloride and H2O. And if I just had to say what they are, well, this is clearly salt and this is water. So neutralization reaction, what happens is, whenever you're having an acid and base combined together, you will always get a type of salt and water. What will you get? Salt and water. Let's take one more example. Preparation of soluble salts by double decomposition, neutralization from insoluble base and acid. Fine. And so let's take a few more examples given in your textbook. Learn all the examples that's given in your textbook thoroughly, because a lot of examples mainly in your paper can come from your textbook. So each and every example given in your textbook has to be learned. Everything in your textbook, all right? Not learned, but just understand them very, very well, all right? So let's take the insoluble acids as CuO plus H2SO4. Again, H2SO4, H2, we all know it's your sulfuric acid, and it's dilute sulfuric acid. So CuO is your base plus H2SO4. So what will happen? Of course, Cu will go with what? SO4, and H2 will come together. So whenever you are actually whenever you're finding a product, always remember, when you have the neutralization reaction, just find how you can combine and how you can find water and salt as a product. So you have CuSO4, which is a salt, plus H2O. Got it? You have soluble salt and you have water. Let's take one more over here, alright? Lead oxide, PbO plus 2HNO3, which is again dilute acid. See, wherever H is there, it will be acid only. In most cases, acid cannot be formed by hydrogen. So if there is no hydrogen in a certain compound, it is not an acid. Always remember that. Alright? Now, PbO plus 2HNO3. So clearly H2O. So these two compounds are together because water is one of the compounds. So H2O comes, then what is left? Pb is left and NO3 is left. So clearly you have PbNO3. But see over here, oxygen is 3 into 2, 6. So what do you do in this case? You make a bracket, NO3 the whole twice, because nitrogen is also 2 times. So therefore it's H2O plus 2HNO3 gives you, PbO plus 2HNO3 gives you PbNO3 the whole twice plus H2O. Fine. Now let's take insoluble hydroxides. Hydroxides as in OH. OH minus is your hydroxide. So let's take copper hydroxide the whole twice, right? So CuOH the whole twice plus H2SO4, again it is dilute acid. So H2O. So as you can see over here, there are 4 oxygen atoms over here, while there are two oxygen atoms over here. So we only need basically, what do we need? We only need one oxygen atom and two hydrogen atoms, right? So what we can do over here is, we'll say 2H2. Why? Because there are two hydrogen and two hydrogen. Fine. Let's cancel both of them. What do? We cancel both of them. Finished. Now since 2 is come over here, your oxygen will also be 2. So you're cancelling this out. So what do you get? You get 2H2O. Done. Then what are you left with? You're left with Cu plus SO4. So your answer will be CuSO4. CuSO4 is again your soluble salt and 2H2O is your water. Fine. Then let's take one more example. Lead hydroxide. Fine. So PbOH the whole twice plus H2SO4. Again the same thing we can do is we'll take 2H2O. So you have 4 hydrogen. Therefore this is cancelled and this is cancelled because 2 plus 2 is equal to 4. Then this is also cancelled out. And what do you have? You have PbSO4 left, don't you? So plus PbSO4. Right? PbSO4. Okay, let's take one more example. PbOH the whole twice plus 2HNO3. Very simple again. So we are taking 2H2O again. Therefore, we again cancel this whole thing and this also. Then what do you have left? You have Pb and 2NO3 left. So again you'll put a bracket, right? Plus Pb bracket NO3 the whole twice. So the whole twice meaning nitrogen becomes 2 and oxygen becomes 3 into 2, 6 and Pb remains 1. So therefore both the sides are balanced now. Fine. So these were your neutralization reactions examples, where when you add or when you when certain compounds or two, let's take two compounds. When two compounds goes through or goes under the double decomposition reaction, okay, two compounds, one of them is a base and one of them is an acid, gives salt and water. Alright. Then preparation of soluble salts by double decomposition neutralization again. So these last two let's take two more examples given below right over here. NaOH plus HCl gives you NaCl plus H2O. Clearly NaCl is your soluble salt plus water. It's basically the same thing that we saw above. So sodium hydroxide plus hydrochloric acid dilute. Then NaOH plus HNO3. So NaOH plus HNO3. So what did I say? Always look out for H2O first because that'll be the easiest of all. So 2 hydrogen you can clearly see over here, that's 1 and 2. So that's gone and 1 oxygen. So what do you get? You get H2O plus. What's left? Na plus NO3 is left. So NaNO3. Perfect. Then you have ammonium hydroxide. So NH4OH plus HCl gives you. So first find H2O as I've always said, right? So you can clearly see 2 hydrogens over here and 1 oxygen over here. So you get H2O. So what do you get? NH4Cl is left. So NH4Cl is your soluble salt and H2O is clearly water. Perfect. So this is done. Now applications of neutralization. A sting of a bee or wasp is acidic in nature. Application of sodium bicarbonate, a basic substance, can be used to nullify the effect. So these are some real life examples where these reactions are actually used. So the neutralization reaction that you see is not only for your textbook, that okay, there's a reaction, it is called the neutralization reaction, and you have one base, one acid, and gives you salt and water. No, it's not only meant for your textbook. These kind of reactions are actually used in day-to-day lives. That is why it's given in your textbook, so that you can remember this in your real life and you can actually use it when, God forbidden, if you ever have a bee stung, you can use this. Then one more, a heartburn due to acidity in the stomach can be revealed by taking antacid. Why? Because it is an alkaline and it neutralizes the acidity in the stomach. That's why. So all the people in the pharmaceutical industry, they all have studied all of this neutralization reaction, etc., and therefore they have come up with a medicine like an antacid that reduces the acidity in your stomach. Okay, perfect. Now let's move on to the energy changes in the chemical reaction. Basically, what are the types of energy changes? What are the types of energy that changes in a chemical reaction or that takes place in a chemical reaction? All right. So first and foremost, what does the term energy changes in a chemical change mean? Energy changes in a chemical change or in chemical reactions is the difference between the chemical energy of the reactants and the products. So you have a difference between the chemical energy of the reactants and the product, and that's your energy change. For example, this is not true. I'm just giving a random example for you all to actually understand. So you have, let's say you have heat in the reactants and your energy changes into some other energy kind. Like, what do you say? So over here you're having evolution, over here in the product side you're having absorption. So you see you have an exothermic and endothermic reaction taking place, and there's a change in your energy. In one, the evolution of heat energy is taking place, but in the other, the absorption of heat energy is taking place. So every substance has a stored amount of energy in it that is potential or latent, commonly called as chemical energy. And a chemical change is associated with the evolution or absorption which is required to break or form different bonds between the molecules of the reactants and products. This energy is in the form of heat, light, or electricity. So mainly concerned with chemical reactions, we have three types of energy changes that might take place or that may take place. One is your heat energy, one is light energy clearly in the reaction of photosynthesis you have light energy, right? And one is electricity energy. Depends on different reactions, you have different energy changes. So surplus energy is released or absorbed depending on the energy of the products and reactants, just as I said. So as with exothermic reaction, a chemical reaction which proceeds with the evolution of heat energy. This we did that before, right? We did this before exothermic and endothermic. So such a type of reaction is called as an exothermic reaction. I even said exo, meaning coming out, or it's coming out. So you have an evolution of heat energy taking place, right? It is coming out. The heat energy is coming out, so you have an evolution taking place. An exothermic reaction can be sustained without the supply of external energy. So plus triangle T, it basically indicates an exothermic reaction. So if you have 2NH3 plus triangle T, this basically says that an evolution of heat energy has taken place. Then similarly 2H2 plus O2 gives you 2H2O plus triangle T. I'm just saying plus triangle T so that's it's easier for you all to understand. So 2H2O plus triangle T. Triangle T basically represents that there's an evolution of heat energy taking place. Then 4NH3 plus 5O2 equals to gives 4NO plus 6H2O plus triangle T again. So there is an exothermic reaction. Similarly, in the case of endothermic reaction, you have minus triangle T because there is an absorption of heat energy. So heat energy is taken away. So endothermic meaning end, that means the heat energy is ended and there's absorption of heat energy taking place. So you have minus. But in this case, you have an evolution, so you have a plus. So it's either minus or plus. Fine. Then other reaction or energy changes are photochemical reaction, chemical reaction in which absorption of light energy takes place. Electrochemical is absorption of electrical energy, right? And then you show such a reaction by the arrow. So you have the arrow, and above, let's say there's absorption of heat energy. So you're writing sunlight. That's your light energy, right? That's light energy basically. So you're writing your sunlight above. Then again, if you have a reaction, say H2 plus Cl2 gives 2HCl. So sunlight and absorption of light energy is taking place. Similarly with electrochemical reaction, again, when you're writing the arrow, that's the give sign. Above you write electric, fine, and below you write current. So this is the difference, and this is how you basically represent it. Perfect. I hope you all understood this part as well. Now let's move on to the conditions for a chemical change. What we basically mean by this is, what are the conditions that are needed for a chemical change? How will a chemical change take place? So a chemical reaction or a change between substance takes place due to the collision of particles when in close contact with one another, or by altering conditions, that is supply of energy, which may be required to initiate a reaction. So by close or physical contact, a chemical reaction can take place, right? No chemical reaction can take place if the reactants are kept far apart. If you want to combine a reaction, see, at the end of the day, even if you have 4 different reactions, decomposition, displacement, double decomposition, and then combination reaction, at the end of the day, something or the other is coming together or they're going apart. So in the case of combination, decomposition, and all of these reactions, in the case of combination, displacement, and double decomposition reaction, even though compounds are going away, some compounds are again combining. So you have some combination over here, and when this combination is there between compounds, you know that a chemical reaction is happening. And when they're together, that means they are in what? Close contact. Similarly, in the case of decomposition reaction, even though they're going apart from each other, once they were together, no, they were in a close contact. So therefore they were in a chemical reaction, but separating them also is one more chemical reaction, and that's why the name comes decomposition reaction. Fine. Let's take an example. Iodine and phosphorus, they react explosively on close contact. Why? Because they're coming together, they're forming one, and then they're vigorously attacking. That means they have come in close contact, right? Then again, contact and solution would be whenever you put something in a solution, you have contact, right? Both the substances are having contact, so a chemical reaction is taking place. Then by supplying energy, heat, light, electricity, pressure, catalyst, all of these, if chemical reactions are brought together by heating as well, they are coming by close contact. And when you supply energy to any of the chemical reaction, of course they will come together and they will undergo a certain chemical reaction. Let's take the example of photosynthesis, right? How do plants make their food? By photosynthesis. So in this case, wherever they get oxygen, fine, they get the sunlight, they get all of that. This chemical reaction at the end is taking place with all of these substances mixed together, and one supply of energy, that is your light energy from the sunlight, right? So all of them are coming together and close contact. Basically all the substances are coming into a close contact, and then you have your plant's food, which is basically glucose. Right? So the supply of energy also matters. Similarly, heat, electricity, pressure, a catalyst that helps chemical reactions go faster and easier, and also sound, in fact, right? So all of these can help in making a chemical change or a chemical reaction. Perfect. Okay. Now let's look at a few questions regarding this chapter, and then there's also a unit test at the end of this chapter. The unit test is pretty hard. I'm not scaring you guys, but it is a little hard. So solve it very, very carefully and see each question. And then you'll understand why I keep telling you to go through the examples and write every example in a piece of paper, because it is extremely important. Take my word on it. Alright? So let's do a few questions and we'll try finishing everything because we've already reached 25 minutes. So let's keep the video till about 35 minutes and let's see how much we can cover. Alright? So instead of doing the additional questions, I'll straight away go to the unit test. All of you can do the additional questions as homework. Always, like always, I'll be waiting for your responses in the comment section below, and please submit all the responses, and if you have any doubts, feel free to post them. I'll be more than happy to solve them. Alright, so let's go to the next page now. Okay, unit test paper 2, chemical changes and reactions. Question number 1. Direct combination reaction of sulfur dioxide with water gives. So what is sulfur dioxide? SO2. And what is water? H2O. So what do you have? You have which gives you H2, and there are 3 oxygen atoms. So 2 plus 1, 3, right? SO3. So what do you get? H2SO3. So tick on the option which says H2SO3. Then you have next question, the question number 2. Formation of hydrogen chloride from hydrogen and chlorine is an example of, well, it is an example of photochemical reaction. Why? Because there is an absorption of light energy, right? So it is an example of photochemical reaction. Take that option. Fine. Then question number 3. The reaction of hydrogen burning and oxygen to give a neutral liquid. Neutral as in neutral, I'm guessing water, of course, because hydrogen plus oxygen gives you water, and a neutral liquid because water has no taste, it has no color, it is a colorless liquid, of course. So it is a neutral liquid. So hydrogen plus oxygen, as we saw just a while ago, it is an exothermic reaction, right? So take on that option. Then we have question number 4, which says the neutral gas evolve and then lead nitrate undergoes thermal decomposition. So as we read before, what is thermal decomposition? Let's take a quick revision on that. Thermal decomposition is nothing but it is a decomposition reaction in which substance deassociates into 2 or more simple substances on application of heat. So the gas that will evolve is, you have PbNO3, right? So what is the gas over here? It's of course oxygen. So that will be the neutral gas, and oxygen is a neutral gas. So that will be the neutral gas which is being evolved, right? Then the 5th one I'll give you as homework. Solve it as homework, all right? Then the second one are also based only on examples, so also go through that, and I'll give you that as homework as well as the third question, because it's basically balancing, and differentiation is very easy. It's all theory based. Whatever you have understood from the chapter, just do that. So if you're saying synthesis reaction and a substitution reaction. So synthesis reaction is nothing but your combination reaction, right? It's just a different word for direct combination reaction, and substitution is displacement reaction. So the difference, you can say, in direct combination reaction you have A plus B which turns into AB. Displacement, you have A plus BC which turns into AC plus B. Then direct combination is just when 2 compounds or 2 elements or 1 element or 1 compound comes together to form 1 new compound, 1 new element, or 1 more new compound. And displacement, it is only displaced in the case of the electrochemical series where its position is. So just like that you can write various differences. Then match the following. Let's do this one, all right? AB gives you A plus B. Of course, it's decomposition reaction. Fine. AB gives you A plus B. Or, I'm sorry, I was too early to speak. Let's keep this away for just 1 minute. AB plus A. AB gives you A plus B would be decomposition. Then x plus y minus, of course, it's radical change, so nothing else, it's double decomposition. Then x plus yz gives you xz plus y. Clearly, it is displacement reaction. Then x plus y under heat gives you xy minus the triangle, minus triangle, we all know what it is. When you're saying minus triangle, that means end. That means you have endothermic, and the first one then goes to thermal deassociation. Perfect. Then the sixth one is very easy. It's just the solid residual substance, so you can do that as well. So with this, we come to an end of this chapter. I hope you understood each and everything from the very start to the very end. And if you have any doubts, post it in the comment section below. I'll be more than happy to solve them. Like, comment, share, and subscribe to our channel, FikarNot.com. Now, FikarNot from studies. And until next time, bye.